Alright, so a square root function, which is what the start is when you take the square root of x. Now, we know what happens when you take the square root of x. You have to have two numbers that multiply to get the same number, right? That's a perfect square. So when you take the square root, if it's 2, you would get a decimal. So this is our parent function. This guy right here. And we are going to graph him. So on this, I want you to create a coordinate plane. Now, we talked about this some when we did quadratic formula. Can we take the square root of a negative number?
No.
No. So we are not going to have negative x values. Just go ahead and start off with knowing that. And that's why it says that our domain, remember domain is your x values, that's x when x is greater than or equal to 0. So we are not going to have negative x values. What we're going to do for this first base function, and this is our parent function, the mama function, the alpha, and the omega, we're going to plug in some x values and see what we get out. Now, does it make sense for us to plug in like 2 or 3 or something that's not a perfect square? Because we don't want to graph a gross negative, right? Like if you take the square root of 2, what do you get? Where's my calculator? It's like 1 point something, 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 something. So if we started by taking, if we plugged in 2, and we took the square root of 2, we would get 1.41. Now, do you really want to graph that? No. So what you're going to do when you graph these, and when you plug them in, you're going to create a table. And you're going to use perfect squares as your x value, or you're going to use some kind of value that's going to get you a perfect square under the radical. So what's the first perfect square we can think of? 1. Okay, what about 0? Does 0 also work? Okay, so let's start with 0, and then 1. What would come after 1? 2 is not a perfect square. We're listing perfect squares. 4, and then 9. Okay, so we're plugging these x values into here. What's the square root of 0? 0. What's the square root of 1? What's the square root of 4? What's the square root of 9? Okay, so this is what the graph of this guy looks like. So at 0, 0, we'll put a dot. And then where will our dot go from there? What will we do? What's our next point? Right 1, up 1. All right, what's our next point? Right 4, 1, 2, 3, 4, up 2. And our last point? 6, 7, 8, 9, up 1, 2, 3. And that's what the graph of a square root function looks like. So it looks like if you cut a parabola in half and turned it sideways, right? That's exactly what it is. That's all you do. Now, why am I not plugging in negative numbers?
Because
You can't take the square root of a negative. It's imaginary. Are you guys ready to practice?
yes.
Are you sure? All right, now you see this guy right here. This is our base form, and it kind of looks like vertex form of a quadratic, right? Do you guys remember vertex form of a quadratic?
Yeah.
I would hope so, because it was just last week. This is the same thing. And HK being your vertex, that's your starting point. So let's write starting point. Now, A has the same properties as before. If A is positive, we're going to have, what could we call this? We're going to have a half arc. But if it's negative, it'll go this way. So what could we call it so that we remember it? I don't even know what that even reminds me of.
Wherever you have to go over, you always go back to the first one.
To the origin? Yeah? Mm-hmm. Alright, so if A is greater than 0, it's going to look like this. With a starting point, and it doesn't go any further. If A is less than 0, it's going to look like this. Now, A can be less than 0 because it's outside of the radical. So it does the same thing as the quadratic where it flips it over. Question so far? No? 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 Okay. Well, let's turn our paper over. 56B. Alright. Graph. Let's call this example 1. Graph each function. Alright, so the first one I want to graph is the square root f of x equals the square root of x plus 1. I'm sorry, this is not nap time. This is not nap time. Alright, so what do you think this plus 1 does? It adds to it, but do you think it's going to move it?
Yes.
Well, what did it do when we had a quadratic? When we had x squared plus 1, what did that do? It moved it, right? Did it move it up or down? Do y'all remember? No? Great. Love standing up and wasting my time. Alright, so we're still going to plug in perfect squares. So let's make a note that says plug in perfect squares for x. Plug in perfect squares. Alright, and again, what's our first perfect square? 0, and then, besides Allah, and then, awesome. Alright, so let's plug in 0. What's the square root of 0? And what's 0 plus 1? 1. Does everybody see where we got that 1 from? Does anybody not see? The square root of 0 is? And 0 plus 1 is? Yep. Alright, what's the square root of 1? And what's 1 plus 1? Awesome. What's the square root of 4? And what's 2 plus 1? Alright, what's the square root of 9? And what's 3 plus 1? So it looks like from our base function that we had before that it just moved up 1, right? Let's see if that's true when we graph it. Oh, Blair. Oh, that line's better. Drive me crazy. Alright, so our first point is 0, 1. So we start at the origin and we go up 1. Alright, where's our next point? So I go right 1 up 2. And then what do I do? Right 4 up 3. 1, 2, 3, 4 up 1, 2, 3. And then what do I do? 6, 7, 8, 9, 1, 2, 3. Now, can I go below this point? Well, if I went below it, I would be plugging in negatives, right? And can I have a negative square root? So you can't go below that point. So it stops at that point, and then it goes that way. So my domain is my x values, right? And what x values can I plug in? Can I plug in negative? Can I plug in positive? Can I plug in 0?
Yes.
So it's x when x is greater than or equal to 0. Remember that worksheet we did on quadratics where you had to label those? Still doing the same thing. And then range, what's our y values? Is our starting y value 0 this time? What's our starting y value? 1. So is it greater than 1 or less than 1? It's going up, right? Greater than. Alright, let's do another one. Does anybody have any questions on this one? Can you try one without me? Yes. You know I'm going to throw something at you if you whisper at me after I heard you cackling yesterday and talking super loud. So say what you need to say with words. What about it? What? What about it? Use your words. What is she saying? Someone translate. Please put your phone away. I can see the glow. It's not an angel landing in your lap. Put it away. Translate. Is it normal graphing? Like where you just plot points? Yes, what we do does not change ever in graphing. We're just plotting points. Alright, B. The square root of x minus 2. Now, since it's minus, do you think it's going to move it up or down?
Up. Yeah.
Pardon?
I thought she said it could.
X can't be negative. F of x can be because f of x is y. So plug in the same x values. Use 0, 1, 4, and 9. Always use perfect squares or numbers that will give you perfect squares. And I have to take attendance if I forgot to take it. We're only missing Josh. Did y'all get that for your table?
Yes.
Negative 2, negative 1, 0, and 1. Awesome. Pardon?
How'd you get it?
What's the square root of 0? What's 0 minus 2? What's the square root of 1? What's 1 minus 2? What's the square root of 4? What's 2 minus 2? What's the square? We're just plugging in.
I don't know, but I put it negative.
What?
It was like negative 2, negative 3, and then I don't know.
Into your x's? But I told you you can't plug in negatives, and I told you what to plug in. Alright, so 0, negative 2 is right here. 1, negative 1. 1, 2, 3, 4, 5, 6, 7, 8, 9. And remember, don't extend past that point. So what's your domain this time? X when x is what?
0.
So when it's greater than what? Your x value, guys. Your x value. 0. Remember, it cannot be negative. It's not a trick question. All right, what's your y value this time? I can't hear when you whisper at me with all the air conditioners going.
Negative 2.
What about negative 2? Is it greater than or less than?
I don't know.
Look at the problem. Is it going up or down?
So it's going like 0.
Are the y values going up or down?
Yes.
Oh, my sweet potatoes. You guys do know that we still have a week and a half left of school, so you still have to learn. Like, we're not done at all. Get it together. Alright, so if I wanted to move it up or down, I add on the outside. What would I do if I wanted to move it left or right? So up or down is on the outside of the radical. Where would left or right be? Inside the radical. Alright, so C. F f of x equals the square root of x plus 2. So this time, I can't just plug in perfect squares, because if I plug in 0, I'm going to get 2 under the radical and we'll get decimals. So this time, I can plug in negative numbers. Now, if I want to start by getting 0 under here, what number do I need to plug in for x? What x value plus 2 will give me 0? Negative 2. Okay? So then what would I plug in next to get 1? Negative 1. And what would I plug in next to get 4? 2. Alright, let's plug in those. Negative 2 plus 2 is 0. What's the square root of 0? Alright. Negative 1 plus 2 is 1. What's the square root of 1? And 2 plus 2 is 4. What's the square root of 4? Alright, so negative 2, 0. I go left 2, negative 1, 1. Right 2, up 2. Look at me go. And it's not a straight line, it's got a little curve to it. So when I add on the inside, what does it do to my radical? Or what does it do to my graph? Does it move it left or right? It moves it left. So this plus, it's still the opposite, just like it was when we were finding our vertex in our quadratic. So is our domain, Blair, domain, what's our x value going to be bigger than this time? Negative 2. Alright, and what's our range going to be bigger than this time? Yep. Alright, so right now what we're going to do is we're going to have a worksheet where we have to match up we're going to match the function to the graphs up here. And it should be in different colors, so I'll find mine with different colors. But, you know, we only have a black and white copier. Alright, can you guys get out 8 colors? And we'll just color them on here. Get out some kind of colors. Red, hot pink, 1, 2, 3, 4, 5, 6, 7, 8. Alright, so on mine, I'm going to start with this first one right here, and I'm going to outline it in green. You choose whatever color you want. Then I'm going to go left and outline this one in pink. This one is going to be blue. This one's going to be this fuchsia color. Are we ready or do we need another minute? What? Yeah. Okay. Y'all sound like the Minions whenever they're sad. That's what it sounds like up here with all the air going and the clacking of the markers. You're going to get your semester exam study guide next Tuesday. Just let everybody know. Tuesday. And then we'll find out if you're exempt on Friday. Alright, so this activity talks about transformations. So what we're going to do is we're going to match the function to its graph. And we're going to start with the parent function. Now, based on what we know with our parent function, which was this beginning one, where are we at? This beginning one that we did, we know that the values are 0, 0, 1, 1, 4, 2, 9, 3. So let's look for the graph that looks like it crosses 0, 0, 1, 1, 4, 2, 9, 3. Which one do you think that is? I don't know what word you said. This middle one right here? My green one? So I think it's my green one too. And the way we can tell is we can go right 4 up 2. It crosses right there. We could go to 9 and it crosses at 3. We could go to 16 and we know that's going to be 4 because the square root of 16 is 4. So you take your color, whichever color you use for that particular graph, and mark it beside it. And I'm even going to write an A at the end. Now, what did we say in our notes happens if A, the number out front, is negative? What did we say it does? The number, X can't be negative, but the number, I didn't explain that, I'm sorry. This number right here, if it's negative, what did we say it does? It flips it over, right? It becomes like, I don't know what it's like. So it's exactly the opposite, but it's the one going down. So that's my red. It's this guy right here. So whatever your color is, but it's this guy right here. So it flipped it over. Now, what do you think this activity is showing us? Kind of, but what is the activity showing us? What is it pointing out?
Like different ways we can graph?
The different ways that we can graph, how the graph changes. So this is called transformations, which if we had more time, we'd do a whole parent function unit, and it's awesome. Maybe one day. Right, C. So plus 5, we did something like that here. And when we had a plus 2, it moved it left 2. So what would the plus 5 do? Move it left how many?
5.
So that is my hot pink one right here. So if plus 5 moves it left 5, bless you, what does minus 5 do?
Right.
Moves it right 5. And remember, both of these are under the radical, so that's what makes it move left or right. If it's under the radical, it moves left or right. So that's this guy. Say it to me again. So plus 5, we said it moves left 5, correct? So then minus 5 would move where?
Right.
Yeah, so we got this one right here. Are we ready for E? Alright, so E is plus 5 on the outside of the radical ends. And we did one like that right here. So when we said plus 1, what did it do to our parent function? It moved it up 1. So what would plus 5 do? So which one would that be? All the way up? So that's this peachy color. This guy is E. So what would minus 5 do? on the outside of the radical, it would move it down 5. So that's F. That's my orange. All right, now we did not graph one with a whole number outside and a fraction outside, right? We didn't multiply. But based on our quadratics and what we know, what do you think it's going to do? What's a whole number going to do? Is it going to make it steeper or wider? I think it's going to make it steeper. But what does that look like on a square root? Because it's not going upside. It's not a parabola like this. So do you think it's going to be my skinny purple line or my high arch fuchsia line? Who votes for fuchsia? All right, who votes for skinny purple? Okay, let's use potatoes. Let's use Desmos and see what happens. I forgot to drink tea. The wonderful world of Desmos and technology. Girls, stop looking at each other. You're not 5. All right, so 5 square root of x. What did that do? So that made it the fuchsia line. All right, so what if I said 1 divided by 5? What did that do? Made it the purple line. So 5 makes it arch this way. So a whole number makes it go up. And then a fraction makes it lie flat. So it's almost the opposite of what we did in quadratics, right? Crazy. Now, I don't know if your paper puts a hole in this, but this should be K. Okay. So that should be K down there. Now, what do the directions ask you to do?
Describe how each variable transforms the parent function.
Okay, so remember our parent function is y equals the square root of x. That's our parent function. Now it's asking what each letter does. So where is A? A is on the outside, right? So I want you in your own words to look at the ones that we did that had a number on the outside, negative, the whole number, and the fraction. And I want you to tell me what each of them did. If it's negative, what did it do? If it's a whole number, what did it do? If it's a fraction, what did it do? Go, do it without me. Tell me what A does to it. Hello. You should be writing. Okay. Pardon?
How come your face is really red?
Because I didn't wear makeup. And I went to the beach Sunday. And today I put on makeup. Because I woke up on time. You got this math? And not worried about my face? Okay, do the math. Thank you. Now, if it's negative, what did A do to the function?
It flips it.
It flips it over. If A is a whole number, what does it do to the function? Makes it go up real high, right? If it's a fraction, what did it do? Almost makes it go straight, makes it lie flat. So you should be using your own words to write that. All right, tell me about H. What does H do? H is on the inside. So when we had on the inside, that was this line right here. When it was a plus, what did it do?
It went up straight.
It moved it to the left. And when it was a minus on the inside, that blue line, what did it do? All right, tell me that in your own words. Hey, Cameron, you don't need your phone right now. And then, when you finish writing about H, what do you think I want you to do? Write about K. crazy.